see both these states, okay, suspend ready and suspend IO or suspend blocked. Let's see what is meant by suspend ready. See, what is meant by a process in ready state? Tell me one thing, what is meant by a process in ready state? If a process is in ready state, it is present inside the RAM, okay, and also it is neither being executed by the CPU nor it is undergoing IO, okay, which it is simply waiting inside the RAM, waiting either for CPU's execution or for IO devices. See, why it is waiting for CPU? Because some other program might be using the CPU. Now, why is it using for the IO, waiting for the IO device? Because there might be some other process which will be using the IO device. For example, two programs might need a printer, right? Now, some other program might be using the printer. That is also possible, right? So what I wanted to really tell is, a process might be, in case if I say that a process is in ready state, it is in RAM, but it is neither undergoing IO nor it is being executed by the CPU. That's what we mean by ready state, right? Fine. Now what will actually, this is actually happening in RAM, right? This is actually happening in the RAM. Our process is definitely in RAM. Now what might happen is, there might be a new process which might be created inside the hard disk, okay? See, as of now our process is in RAM, fine. Let us assume our RAM is completely full, okay? Some process has been placed, lot of processes has been placed, and so our RAM is completely full and there is no process, there is no space to place any process, okay? Now let us assume a higher priority process is being created, okay? Let us assume the name of, let's name the process as P8, okay? Now P8 has the highest priority and this process needs to be executed by the CPU. Now how is it possible? In order to get executed by the CPU, this process has to be present inside the RAM, right? Else it is not possible because our CPU cannot access the hard disk directly. So this process has to be moved into the RAM. Now the problem here is our RAM doesn't have any free space, right? So what we should be doing is, we should be moving one of the processes from RAM to hard disk, okay? We should be moving one of the processes from RAM to hard disk, making way for process P8, okay? Which means P8 will be moved from hard disk to RAM in place of that process which is removed, okay? This is what we mean by swapping. We have already seen this in a slight manner. We didn't see it in detail, which means moving a process from hard disk to RAM and then moving some other process from RAM to hard disk. This is what we mean by swapping. This is called as swap in, this is called as swap out, okay? So swap in and swap out combinedly called as swapping, okay? Now what is actually happening is, the process which is present inside the RAM, which let us assume P1 is the, we have decided that, who will decide? It is being decided by a long term, it is being decided by your medium term scheduler, okay? We have seen it. Long term scheduler decides how many processes should be moved into the RAM, whereas short term scheduler decides which process should the CPU execute next, whereas medium term scheduler decides which process in the RAM should make way for the new process which is coming from the hard disk and its priority is higher, okay? We have seen it already. If you are not very sure of it, please go back to the video and watch it, okay? Now what I wanted to really tell is, let us assume our medium term scheduler has decided that P1 is the process which has to be moved from RAM to hard disk because P8 needs to move into the RAM, okay? Now what is actually happening is, this process P1 is in ready state, okay? That is definitely for sure. Process P1 is in ready state. Now this process in ready state is actually moving to here. P1 is moving from here to here, right? This process in ready state is actually moving to something called as suspend ready state, okay? It is actually ready to execute, but due to priority we are moving from RAM to hard disk, okay? That is what we mean by suspend ready. So process P1 is in suspend ready state, okay? Whereas process P8 is moving from new state to ready state, right? And again, and who knows, once it goes to the RAM, it can immediately be executed by the CPU. But in that case, it is moving from ready state to running state. That is fine. But one important point I want you to notice here is, due to priority, we might have to swap out a process from RAM to hard disk, okay? The process which we are actually swapping out is actually moving from ready state to suspend ready state, okay? Fine. So a process has been suspended and it has moved to suspend ready state. Now let us assume the high priority process has been executed and it has completed its execution and it has been removed completely from the RAM, okay? Now what has to happen? there will be some space in the RAM, and so we might have to move the process which we have swapped out, right? Which means we might have to swap in this process, okay? That is what we are doing it here. We are resuming that process from where we left out, okay? We might have executed some parts of the line, some lines of that process, right? So we are resuming that process by, see, we are not actually executing. We are by resume I mean we are moving to the ready state. After moving to the ready state, when should this process be executed is being decided again by our scheduling algorithm, okay? Short-term scheduler. We have seen it, okay? Fine. This is what is actually happening here. Now, what might happen is, see, what is this suspend IO or suspend block state? Again, the same thing, same explanation which went there also goes here, also applies here, okay? Here, what is happening is, a process is an IO state or block state, which means a process is actually reading or writing some data from IO devices. That's what we mean by IO state or block state, right? Now, what might happen is, again, see, again, this is also happening inside our RAM, right? Definitely, this is also happening inside our RAM. We have seen it. Whenever a process moves from hard disk to RAM, there are three possibilities. Either this process can undergo IO, or this process can be in ready state, which means it is in RAM but neither executing nor performing IO, or this process can be in ready state, or this process can be in running state, which means it is being executed by the CPU. We have seen it. Okay. Now, this is the IO state is definitely happening inside the RAM. Now, what might happen is, there might be some, again there might be some, the same reason, there might be some high priority process which doesn't have space inside the RAM, and so we might move a process in IO state inside the RAM to hard disk, okay? That is what we are actually doing it. A process in IO state is going to suspend IO state. When will this happen is, whenever we want to swap out a process from RAM to hard disk, okay? Due to lack of space for higher priority processes, okay? That is what we are doing. And once this IO is done, once the higher priority process leaves, which means once the space becomes free inside the RAM, we again resume that process by placing it in the by placing it back to the IO state. In case if the space becomes free, okay, let us assume there is no space inside the RAM still, but this process has completed its IO. See, actually this process is doing two things right now. It is actually performing IO, fine. Now when it is performing IO, it is moved to the hard disk, right? Now it is in hard disk. Also, it is undergoing IO. See, IO can be done even inside the hard disk. A process need not be present inside the RAM to do IO, okay? It can even be inside the hard disk and still continue with its IO, fine. It is undergoing IO, okay? Now, in case if it has completed its IO, this process has to be moved back to suspend ready state. Why? Because it has completed its IO, fine, but still there is no space inside the RAM, so I cannot move to the RAM, but it can be in the hard disk, but it is being ready to move to ready state, okay? It is suspended because of lack of space, but still it has completed its IO, which is as good as saying that this process is in suspend ready state, right? Which means once the space becomes free, it will move to the ready state, okay? That is what we mean by. Now, in case if the space becomes free, but it is still undergoing IO, in that case what it is supposed to do? It is supposed to move back to IO state, okay? Because it needs to further perform IO, right? That is what we have seen. The space became free in the RAM, but still it is actually performing IO. In that case, it is deserved to go to IO state, okay? So this is what has been explained here. Okay, that is all about this diagram, okay? I think by this time you should be very clear about the basics of operating systems, right? At least a very good understanding of how operating systems work and all this, okay? Fine.